Welcome to Asad IT Network. This is free complete series of CCNA routing and switching. We request you to subscribe our channel and share our videos to help spread this free series of videos. Thank you. Today the topic of discussion is the transport layer. It is layer 4 in the OSI reference model. It provides us the transparent transfer of data between hosts, and it is also responsible for end-to-end error recovery and flow control. Flow control is a process of adjusting the flow of data from sender to the receiver, and we have to ensure that the receiving host can handle all of it. There is always a mechanism on the receiving side to handle all the data coming from the sender side. The session multiplexing. Session multiplexing is a process by which a host is able to support multiple sessions at the same time, and it can manage all the individual traffic streams over a single link. We will see how the multiple sessions can be created at the same time and how they are helpful for multiple traffic streams over a single link. Here we have a sender on the left side and two receivers on the right. The sender wants to send some email traffic to the receiver, and it has created a session for this traffic by using the port number 25. We will discuss the port numbers in details later in this section. The sender also wants to send some web traffic to the receiver. It also has created another session for email traffic for the receiver at the below side. So here we have seen that the sender has created multiple sessions, the 3 sessions at the same time on a single link for different type of traffics. Layer 4 port numbers. The layer 4 destination port numbers is used to identify the upper layer protocols. Let's go back onto the previous slide. Here we see that for the email traffic, the sender uses the port number 25, and for web traffic it is using the port number 80. So it means that to differentiate between different type of traffics, we use the port numbers at layer 4, the transport layer. The HTTP traffic, which is web traffic, using the port 80. The SMTP, which is simple mail transfer protocol, using the port 25. So these are different type of port numbers to differentiate between different type of traffics. When the session is created, the sender adds a source port number to layer 4 header, and the combination of source and destination port numbers are used to track the sessions whenever we are going to send or get back any data from the receiver. Here we will see the working of port numbers in details. The sender wants to send some web traffic to the receiver at port 80, and it is using the port 80 as its destination port number, and it has added source port number as 1500 in its packet header at layer 4, the transport layer. We see that whenever the data will come back from receiver to the sender, it has reversed the port numbers, and now the destination port number is 1500 and the source port number is 80. It means that the data is coming back from web server to the sender. TCP and UDP are the most common layer 4 protocols. TCP is connection oriented, and once the connection has been established, the data can be sent bidirectionally over that connection. TCP also carries out sequencing to ensure that all the segments are processed in the correct order and none of them are missing. TCP is a reliable protocol. It means that whenever the receiver receives any kind of data, it has to send an acknowledgement back to the sender, and if the receiver does not send any acknowledgement, it means that the sender will consider it as the data has been lost and it will resend that data again. TCP also performs flow control. It means that it always ensures that all the data which was sent by the sender has been received at the receiver side. The TCP uses three-way handshake process to establish the connection. The sender sends a sync message to receiver, and it means that the sender wants to build a connection with the receiver. The receiver will send back an acknowledgement of sync message, and it means that the receiver also wants to add or establish a connection with the sender. The sender will send the acknowledgement, and it means that the connection has been established successfully. Here we have the TCP header. At the top we can see that we have source port number and the destination port number. We also have sequence number and acknowledgement number to ensure the flow control. We also have different bits for header length, reserved, code bits, windows, checksum. These all are used to handle all the flow control of the data and to avoid the error recovery at the data. And at the end we have data UDP. UDP is not connection oriented. There is no handshake connection set up between the hosts. UDP does not carry out sequencing to ensure segments are processed in the correct order and none are missing. And it is also not reliable. The receiving host does not send any acknowledgement back to the sender, and UDP does not perform flow control as well. We can see that the UDP header has much less fields than the TCP header. It only has the source port number, the destination port number, then we have the length and UDP checksum, and then we have the data. So it has much less fields than TCP header. If we compare the TCP and UDP, we can see that application developers will typically choose to use TCP for traffic which requires reliability. It means that whenever we require the reliability of the data, we are going to choose TCP over UDP. And real-time applications such as voice and videos, they cannot afford the extra overhead of TCP, so they use UDP. We have seen that the TCP has much fields in its header, so it has a bit of extra overhead which is unavoidable at in real-time traffic. So the real-time applications do not use TCP, but they use the UDP. Here we have the applications which uses the TCP. This is FTP file transfer protocol use 21 as port number, and Secure Shell also uses the port number 22. Telnet uses 23 as the port number for the session creation, and HTTP uses 80 port 80 number, and HTTPS, the hypertext transfer protocol, this is encrypted traffic. For encrypted traffic it uses 443 as the port number. The UDP uses trivial file transfer protocol, uses 69 as the port number. The SNMP simple network management protocol uses port 161. The TCP and UDP, the DNS with the port number 53 can be used by TCP, or it can be used by UDP as well. So this was all about the transport layer. Hope you have learned some useful knowledge about the TCP, the UDP, the transport layer, and thank you, and please subscribe to our channel and help us to spread this free series of videos. Thank you.